Hi dear students, welcome back to computer science class. In our previous session we have seen why we including main function in a program, right? Main is just like a function. It has no importance, any special importance in Python, okay? But we have two methods of calling main function. One is explicit calling, another one is applying the script if name equal to main, okay? Then today we are going to discuss a very important topic in any programming language, okay? It's called recursion. You know the term meaning of recursion? Recursion means calling something in terms of itself, okay? That is what actually recursion is. It is one of the most powerful tools in a programming language, okay? It is a function calling itself again and again. It is a function calling itself again and again, or we can say it can be defined as defining anything in terms of itself, okay? Defining anything in terms of itself. That is what recursion is. And in this session we will be looking at the conditions to be applied for implementing recursion, then disadvantages and two parts of recursion, okay? The concept is very simple. As I said, recursion is a function calling itself again and again, or simply we can make it very simple, okay? Suppose we are defining a function. In our previous program we have seen, okay, in our last program we have seen a function area rectangle, right? Okay, area rectangle. And first we have defined area rectangle, then after that, after the scope of area rectangle, the function, we are calling the function, right? That's a normal way of doing, a normal way of defining and calling a function. But when we try to change it to another routine, that is when we include the calling statement of area rectangle within the scope of area rectangle function definition, it's called recursion. From the definition part of area rectangle, we are calling area rectangle, or we including the calling statement of area rectangle inside the definition part of area rectangle. We can call it as recursion, okay? The concept is very simple, okay? Then let's see some of the conditions for implementing recursion, okay? One is there must be a terminating condition. There must be a terminating condition. That's called base case, okay? What is a terminating condition? If we don't have any terminating condition, what happens? It may be going endless, okay? There won't be any end in the repetition or recursive process, okay? So that is what, there must be a terminating condition, okay? And we are applying the terminating condition using if. Simple. We are applying the terminating condition using if something, that is the condition, and that should be the condition for ending the recursion process or recursive process, okay? Then reversal in order of execution, that's another important feature of recursion. Reversal in order of execution. What is a reversal in order of execution? As I said, there will be number of times the function gets called, okay? Number of times the function gets called. For example, reversal in order of execution, okay? Suppose the first time function is called, it won't be getting executed immediately after it is called, okay? Other than executing immediately, it will be placed onto a stack, okay? For the second function calling, the same happens. It won't be executed at the time, it will be placed onto the stack, okay, above the last call, okay? Now we have two calls, okay? And suppose the third time the function is called, what happens? Now we have two elements onto the stack, two function calling, and the third will not be executed suddenly, will not be executed immediately. It will be placed onto the stack just above the second, okay? And which one will be, okay, suppose we have only three function calling statements, which one will be executed first? The third one, right? Only after completing the execution of third, it will be executing the second, and it goes to the first, okay? So we have placed first, second, third. We are placing in this order: first, second, third, fourth, okay? And which one is executed first? Fourth, then third, then second, then first. It follows LIFO, last in, first out, okay? Let's say an example. We have a stack. Okay, we have a stack. You know, what is the specialty of stack? Stack is a data structure that follows LIFO, last in first out processing order. Okay, last in first out. Last in first out is what inputted item can be taken out first. Only the last inputted item can be taken out first. Okay, second last second. Okay, yeah, that is the order. Okay, then you can see the structure. Only one end is open, the other end is closed. Okay, suppose we are pushing, the process is called pushing. Okay, we are pushing some books. Okay, yeah, first we are pushing maths book, maths textbook. Okay, your math. Okay, which will be placed which moves to the bottom of the stack. Okay, then you're inserting, you're pushing your physics. Okay, then chemistry, then your computer science. Okay, actually we have placed math first, physics second, chemistry third, and computer science last. Which one will be executed first? Of course, computer science, because only computer science can be taken out first, because we don't have any opening here. Okay, so we can take computer science only first. Okay, then after executing computer science, we have placed in which order: math, physics, chemistry, computer science, and in which order it is getting executed: computer science, chemistry, maths, physics, maths. Okay, in reverse order. Okay, computer science will be taken out first, executed first, then chemistry, then physics, then maths. Okay, so this is what a stack is. This is what a stack is. And here in recursion, actually all the function calling statements are placed onto the stack, and the execution is reverse. Okay, in reverse order. Okay, yeah. The last one, new memory space is allocated to local variables. Okay, in each function call, new memory space will be created or allocated, okay, to local variables associated with the function call. Okay, so these are the points to be remembered at the time of implementing recursion. Okay, the first one is there must be a terminating condition, that's called base case, otherwise it may be going endless. Okay, then there must be an if condition, and using that if condition we implementing the terminating condition. Okay, that is what terminating condition is. And third one is reversal in order of execution. When we call a function, it will not be executed immediately. Instead, it will be placed onto the stack. Okay, and it will be executed. It will start executing only after completing the placement of the function calling, or the condition becomes satisfied, or the end condition is reached. Okay, then new memory location will be created during each function call for local variables. And the specialty is local variable maintain the same name but with different set of values. In each function calling, variable gets different set of values. Okay, different set of values but with the same name. Okay, let's see an example. Okay, then disadvantages. Consume more memory. Okay, it consume more memory because it create or it allocate memory during each function call. Okay, so it consume more memory than the normal routine. Okay, then run out of memory. It may run out of memory. How? Because if there is no ending condition or terminating condition, if it doesn't satisfy the terminating condition, what happens? It may go endless. Okay, so it may run out of memory. The last one, it is less efficient in terms of speed and execution time. In terms of speed and execution time, recursion process is less efficient. Okay, let's see the two parts of recursion: terminating part and recursive part. What is the terminating part? As I said, there must be a terminating condition, otherwise the recursion process may go endless. Okay, without any end. Okay, so it consumes more memory, it may run out of memory. Okay, it may be less efficient. Okay, yeah. Then recursive part, that is the main part. Both are important. Okay, both are main. Okay, recursive part means the function calling statement. That is a function calling statement, or that part is called recursive part. The part which does the recursion process. Okay, is called recursive part. So this is somewhat a theory part of recursion. let's have a quick revision. Okay, recursion is one of the most important topic or the concept in any programming language. Okay, one of the most important topics in any programming language, and it is also the most powerful tool also. Okay, and what is this? A function calling itself again and again, or defining something in terms of again what itself. Okay, defining anything in terms of itself. And how we implementing it? Just by including the calling statement of a function inside the definition part of that function. Simple. It is that simple. Okay, including the what calling statement of a function inside the definition part of the same function. Through this we can implement recursion. Okay, then let's see some of the conditions to be applied. Terminating condition must be there, otherwise there won't be any end. Okay, that's called base case, and we are applying it through if condition, and new memory location will be created for variable during each function call. Then reversal in order of execution. We know there will be multiple function calling statements. Okay, this calling will not be executed immediately. Instead, this calling will be placed onto a stack, and these are executed in reverse order. That is what a stack is. A stack is a data structure following what? LIFO, last in first out. Then disadvantages: consume more memory, then run out of memory if there is no terminating condition, then less efficient in terms of speed and what? Execution time. Okay, then recursion has two parts, terminating part and recursive part. Terminating part means that's both are important. Okay, terminating part, the part which meant to terminate the recursive process, and recursion part is the part that does the recursion. Okay, now let us have an example for recursion. We are finding factorial of a number. You know what factorial is? 3 factorial equal to 3 into 2 into 1, that is equal to 6. Okay, then 4 factorial equal to 4 into 3 into 2 into 1. Okay, so we are finding factorial of a number using recursion. Here we have a definition part, def factorial, which takes parameter n. If n equal to 1, return n, else return n into factorial of n minus 1. We know what it is. It is a function calling statement. Then we initializing num. Num equal to int of input of enter a number. You can enter a number, by default we know it takes as a string. Okay, so using int of, with typecasting it to integer type. Okay, so that number will be stored in num. Let us have a value for num, that is 3. Suppose we are having 3 in num. Okay, we initializing num with 3. Then print factorial of num is factorial of num. Here what is this? It is also a function calling statement. So at the time of reaching here, it calls a function factorial. So factorial of num, we are passing one value. Why? Because here we have only one formal parameter, so we must have at least one actual parameter. Okay, so we are passing 3. The value of num is, we know it is 3, so we are passing 3. Okay, so that 3 will be passed to the definition part of the header part of the function, that is here this n gets 3. Okay, then it checks whether if n equal to 1 or not. Here the value of n is not equal to 1, though, so it moves to what else part. Okay, return n into, what is the value of n? It is 3. 3 into factorial of n minus 1. Factorial of n minus 1, the value of n minus 1 is, n is 3, n minus 1 is 2. So factorial of n minus 1, it is another function calling statement, right? Okay, we know we are making use of a stack to perform this operation, operation of recursion. So we can have a stack. So the first function calling, it is factorial of 3. Okay, so it will be placed onto the stack. Okay, it moves to n, it gets n, so n into factorial of n minus 1, that will be placed onto the stack first. So that is 3 into factorial of n minus 1, 2, that will be placed onto the stack. Okay, so factorial of n minus 1, it is another function calling. Through this we are making recursion. You know what recursion is? A function calls itself. Okay, or implementation, we are what? Including a statement, that is a calling statement, to the same function inside the header, what? Definition part of that function. Okay, that is in the definition part of a function we are making a calling statement to the same function. That is what recursion is. Okay, so n into factorial of n minus 1. 3 into factorial of 2 will be placed onto the stack first. Okay, so factorial of 2, it's another function calling statement. Here n gets the value 2. Okay, it checks n equal to equal, it's not, then it moves to what else, n into, what is the value of n? It is 2. Now the value of n is 2. Okay, 2 into factorial of n minus 1, the value of n is 2, 2 minus 1 is 1. So that will be placed onto the stack next. Okay, that is 2 into factorial of 1 will be placed onto the stack. Okay, so factorial of 1, it's another function calling. So it passes to the header part and receive what? The value 1. Now you can see what n equal to 1. At the time it returns n, the value of n, that is 1. 1 will be returned to the what? Calling statement, to this calling statement. We know in the case of recursion, inside the definition part of a function we'll have the calling statement. That calling will not be executed immediately. Okay, this calling will not be executed immediately. Instead, these are placed onto the stack. And you know what a stack is? A stack is a data structure which execute in LIFO order, last in first out order. Okay, last input item will be what? Taken out first, will be processed first. Okay, so here the value of what? Which one will be executed? Actually, in effect, here we have 3 also, 3 into. Okay, we have 3 into, but factorial of 1, it returns to factorial of 1. We know the value of factorial of 1. It is, which one will be executed first? This statement, right? Factorial of 1, we know the result of factorial of 1, it is 1. So that will be executed first, and it will be taken out first. Okay, this statement will be taken out first. After that, 3 into what? Factorial of 2, that is 3 into 2, 6 will be executed. Okay, so this is how recursion works. This will be executed first. After that, this will be taken into consideration for execution. Okay, so that is what a stack is, following last in first out data structure. So here we know what n returns 1 at the time. Here this is the base case. Okay, this is the base case. At the time it returns 1. So in effect it will be what? 3 into initially, then factorial of 2. That is again factorial of 1. Okay, 1, the result is 1. Then 3 into 2 into 1. That is 2 into 1 is 2. Then 3 into 2. That is 6. Okay, so that 6 will be returned to the function calling statement, to this function calling, and it prints 6. That is factorial of 3 is 6. Okay, this is how recursion works. That is, we had our first function calling factorial of num. At the time control passes to here, and n gets 3 not equal to 1. So the first 3 into factorial of 2 will be placed onto the stack. Okay, then 2 not equal to 1. 2 into factorial of 1 will be placed just above the last function calling, meaning we know the function calling statements are not executed immediately. Instead it will be placed onto the stack. Okay, these are placed onto the stack. Then the topmost one will be executed first. After that it moves to the second, after next to the third. Okay, and so on. Okay, that is execution order. Okay, so finally we get the result. It returned to what? The calling. Here the case, in this case, print what? The result will be factorial of 3 is 6. Okay, this is how recursion works. Hope this is somewhat very simple. Okay, you have a number of examples in your textbook. Just go through it and have more practice on this topic, because it is, as we know, it is one of the most important tools in a programming language. Okay, the concept is very simple. A function calls itself. Okay, or implementation wise we can say including a calling statement to the same function inside the definition part of that function. Okay, that is what recursion is. We have seen a number of advantages and some drawbacks. Okay, yeah, so this is all about recursion. Hope you understand the topic. Okay, have more practice on examples, using examples. Okay, so thank you for watching. Have a nice time.